any longer. Okay. So I guess, getting to the point of it, why are we here? What are we talking about today? UL9540, it's a relatively new standard applicable for residential and commercial energy storage systems. It is a supplemental safety and compatibility standard that is going to be enforced regionally. I guess it'll be specifically, who you're addressing with in terms of inspectors and the like, but definitely states like California are hot on this, and it's coming up as a rapid fire question, probably one of the most asked questions we get in terms of particularly standards and electrical safety standards. So what we want to do is basically cover off with you what UL9540 is, the process that we had to go through collaboratively with Schneider Electric and Discover Battery in order to achieve that standard, and then also provide you with the resources and things that you will need in order to pass on to your local inspector or AHJ, such that it can speed you through the permitting process. So what is UL9540? It's, again, a recognized safety standard that was published and drafted by UL with a consultative group. It is a certification, much like any other standard, be it our current battery standard for safety in stationary solar applications, which is UL1973, or on the inverter side of the business, the more pertinent for them is UL1741, particularly with the SA supplement. As those standards are issued, it's a pretty exhaustive and non-trivial process for vendors to go through this. Okay, they really dive into it. It is a safety standard, so they're really diving into everything from failure modes of a potential product to what happens worst case to other compliance and compatibility type of issues. With 9540 specifically, what it is it's addressing the compatibility between your power electronics, in other words, your hybrid inverter in this case, and your energy storage, which is your lithium battery in our case. Okay, to ensure that they are compatible with one another, they work and play nice in terms of just overall operation, and fundamentally that they are safe and can provide your customers and clients, the homeowners, with the peace of mind to understand that these two devices that are working together as a system are verified and validated to work together and to be safe in that application. Okay, it's a standard that's, again, we can, in our particular case with Schneider and Discover, we achieved our UL9540 certification through CSA. I believe that's the Canadian Standards Association. It is an NRTL, or nationally recognized testing laboratory, in the same vein as UL itself, in the same vein as ETL, TUV in some cases, depending on regions of the world you're dealing with, but it's a formally recognized laboratory that's independent of the vendors. As far as, Jack and I were waxing poetic a little bit yesterday and talking about, the origins of UL9540 from what we've seen. And we both believe that started being kicked around and discussed in 2016. However, the earliest reference of it in the National Electric Code was in 2017's release. So that said, and as you're probably all aware, inspectors from region to region, county to county, quite often reference different levels or different historical references of the NEC. In this particular case, we've gone through 2 iterations now, so it's very commonly required, and most inspectors are very aware of this. That said, again, regionality is everything, and your local regional inspectors, who you probably have a relationship with, are, should be discussed for what they want to see and what they want to require. Suffice to say that by the time we're finished this presentation today, you should have all of the material you need to pass on and get a permit from your local AHJ using the combination of our batteries, from Discover's batteries, and Schneider Electric's XW Pro inverter charger. Okay, and just to be clear on this, because there is some confusion, and it is, as I mentioned, a difficult process, so and expensive process. So many vendors might not be able to go through it. Their product might not be able to pass this particular test and standard themselves, and or they don't have the resources, either financially or engineering wise, to basically accomplish this testing standard. I just want to reinforce to you that there is no ability to self-certify or self-declare for UL9540. Okay, if you have this listing, you should have documentation from an NRTL that shows this. That's what an inspector would be looking for. And typically, if you can hand that over, the permitting process will be a snap. Okay. Another thing I want to reinforce with you is this is a standard that basically collaborates or accommodates the two pieces that we're talking about, power electronics and energy storage, in a system. So you cannot, Discover can't, for instance, have a UL9540 listed battery generically with any inverter. Neither can Schneider Electric have a UL9540 listing on their XW Pro that's generic with any other batteries. Okay, it's a specific combination of power electronics and energy storage that have been tested together to work for both safety and fail-safes and overall performance. You can move on to the next slide now, Matthew. Thank you. Okay, so as I mentioned before, it's a pretty exhaustive set of requirements to go through this. In our particular case, in a collaboration with Schneider Electric on this, who we've had great luck and a great working relationship with over the years. It was a fairly easy introduction to agree to that we wanted to proceed with this. Basically, in addition to the safety standards that have been required for individual components, and I mentioned before, 1741 SA is the relevant standard for power electronics in a grid-connected residential home. As battery standards, similarly for stationary storage, the standard is UL1973. Now, each of our products are standalone, have these relevant standards. And you do need these, or it sure fast tracks things if you have these underlying standards for your particular products ahead of time. But the UL9540 certification is over and above that, and it combines basically the operation of both those devices together. Again, as I mentioned with you in the previous slide, it's adjudicated and or issued, or you collaborate through a third party. It's a neutral third party, which is a nationally NRTL, for lack of a for an abbreviated term, UL, CSA, TUV, ETL. There are a number of agencies like that, but they are specific to that. They test two standards. In this case, they're testing to the UL9540 published standard. One of the most exhausting aspects of going through in terms of engineering wherewithal and providing test results and test reports and things from our respective organizations is a process known as FMEA, or its failure mode effect analysis. And essentially what that process is you are looking at if then scenarios, and usually in the worst case, not the best case, but if then scenarios that basically display or define how the products behave if bad things happen. Okay, and they do, but if there's a dead nuts short, for instance, on the DC bus, what happens to the inverter? What happens to the batteries in that case, and how does it handle it? Is it safe in that combination if that happens? If there's an AC short, if there's a runaway control board, if there is you lose a cap bank, if our FET board doesn't close or our supplementary protection doesn't work, what is the worst case? How does it happen? And how do those two products react together? And ultimately, are there fail-safes built into the system such that they are safe in the event that one of those particular items happens? Okay, so in that, you can see that you're required at that point in time to look at a very specific inverter product or products, and a very specific battery and battery products, and that the collaboration of those and how they interact in the event of these different scenarios is very important. That's why the standard is specific and defines, in our particular case, a listing between Discover AES batteries and Schneider's XW Pro inverter charger platform. Okay, it's the safety standard is there, much like any other safety standard applicable to an industry. It's there to assure that their products are safe in the application they're being installed in, and it's designed to provide some level of comfort to both you and your clients in that the products that are being installed in their home have been approved for that use, have been tested for that use, and are safe. Okay. We can go into any number of questions with you afterward, and please don't hesitate to raise a hand. We will have a Q&A afterward, but at this point, we'll skip to the next slide where Jack is going to cover the combinations.
Yeah, thank you, David. So really happy to be here. I'm really proud of our teams for getting this certification. UL9540 it's a hard requirement in many states in the Northeast, and it's a de facto requirement in California. What we have here is a matrix of the different combinations of XW Pro inverters and Discover AES batteries that went through certification. So we have 1 and 2 inverter solutions with battery banks up to 20 kilowatt hours. So this is the matrix that is actually on our certification document. So when you show this to an AHJ, they will see these combinations and it should be no questions asked. If you look on the far right side, there are some recommendations for power levels. These aren't hard requirements, but these are kind of just guidelines based on Discover standards, which I think David's going to talk a little bit to later in the presentation. So any one of these combinations, if you do an installation with this, it should be no questions asked, that you can just show the AHJ. Now, one of the big questions is going to be, okay, well, what if I want to do a bigger system, 3 inverters or a larger battery bank? This is kind of a gray area, but we think that this should be allowed. What I would recommend doing, though, is definitely take that configuration and show it to the AHJ. It's really going to come down to their interpretation, but we have a lot of systems installed with Discover that are 3 inverter, even 6 inverter solutions, 3-phase, and 3 inverters, 4 inverters, single phase, and much larger battery banks than 20 kilowatt hours. Go on to the next slide.
Yeah, so picking up where Jack left off there, just a quick overview on some of the batteries. Actually, Matthew, would you just go back to the previous slide for 1 second? So just to point out here, again, as Jack mentioned, these are the combinations of inverters and batteries. There are 2 battery models there that we'll be talking about in the next slide. The one thing I want to just be clear about in terms of energy capacity is when we go through UL9540, the letter of the law or the ratings, as they were, are the battery ratings for their useful capacity, not their gross capacity. So what you're going to see in the next slide, and you can forward now, Matthew, is okay. So I just want to be clear here that our battery model that is compliant are the 2 that we're referencing on this are our 7.4 kilowatt hour battery, when that's the gross capacity or the nameplate capacity. And then the useful capacity of that battery is 6.65 kilowatt hours. That is not an accidental useful capacity either. If you do the math on it, it's probably as near as we could get in terms of ratings to have 3 batteries be under the 20 kilowatt hour limit. Okay. Conversely, or in a complementary to this, we do have a smaller battery model. It's a 3 kilowatt hour battery designed for, I'll go into some of the features of that, but basically that's designed to allow you some design flexibility such that you can do current handling with multiple BMSs, but still have a small capacity battery. And everyone knows in the lithium game, you're paying for your kilowatt hours. So trying to keep that capacity down and current handling high is important. But those are the 2 battery models we cover there. They are the only 48 volt models, and XW Pro being a 48 volt inverter charger, that's kind of the table stakes for that. What I want to point out, just what we're covering the batteries here in terms of their specifications or the features that are useful for this, and actually are ideally implemented when we pair our batteries with the Schneider Electric XW Pro. First of all, we're the only battery that I know of in North America, lithium battery for stationary solar, that is a 1C continuous charge and discharge. Okay, you have a 130 amp hour battery on the left and a 57 amp hour battery on the right. Both of those can, the battery on the left can handle 130 amps continuous charge and discharge, which is your 1C rating. The 3 kilowatt, 57 amps continuous charge and discharge. They also both have industry-leading surge and inrush handling. I'll go into some of the specifications there, but suffice to say, this battery can handle a lot of current thrown at it in short-term bursts, such that with one battery, we can accommodate the entire surge rating thresholds for the XW Pro. Not necessarily a recommended solution, and we'll talk about that why in the next slide when I talk about design considerations, but it's definitely a capability there. The same goes for our 3 kilowatt battery. It's got a very high tolerance. I believe it's in the nature of 220 amps. You can draw from it in short bursts of 3 seconds or less. The other thing to recognize is that these batteries, when they're paralleled, the current handling scales linearly. So if you've got 130 amps continuous charge and discharge on the big battery with one, if you parallel 2 batteries, that goes to 260 amps. 3 batteries, 390 amps continuous, and so on, as does the surge. It's linear. Both of these batteries are enabled with 2 CAN channels, or a CAN channel that basically allows them to be closed loop integrated with the XW Pro. We'll go into a bit of detail with you on what closed loop communications are, but essentially it's a direct communication link between the battery and the inverter charger that allows for some useful functions in terms of status updates, SOC for instance. It allows us to push our data log information through the XW Pro, through their really elegant Insight and cloud portal, so you can do remote monitoring, control, and system configuration. Okay, it also automatically pre-populates all of the settings that would be relevant to charging and discharging of the battery bank, and it allows us to basically, in a leader-follower scenario, or formerly known as master-slave sort of scenario, it allows us to command and control the voltage settings throughout the charge profile. We call that dynamic charge management, and that basically assures longevity of the battery. We'll have a longer expected life in those scenarios because we're ideally charging the batteries. And secondarily, an added bonus is it charges the battery much quicker. About a 25% reduction in recharge time from empty to full. Okay. Furthermore, unique to our battery is the ability to basically access the battery's BMS data logs and the internal storage, such that you can pull lifetime data logs from that battery. You can install and upgrade firmware through the course of its life, so that the battery you buy today isn't necessarily static on the wall or on the floor and remaining there for the next 10 years. It will actually benefit from the achievements and the improvements we make in BMS operation, algorithms, all these types of things over the course of time. Okay, now that we've introduced the battery, I want to go into a bit of the design considerations for these systems, and we'll cover that off quickly, and then we'll move on to the XW Pro. Yeah, thank you, Matthew. So this is just a quick overview for you, and I bring this up every time we do a presentation because of the fact that in the lead world, where most of these battery-based systems came from in their origins, it wasn't really a consideration. But with any solid-state battery or electronic battery, if you will, there is a current limiting capacity, and that's the BMS and how it can handle current. I've mentioned before that we have sort of industry-leading current capability on these in terms of surge and continuous ratings, but that said, you still need to design your battery banks based on the inverter draws that you want to do and your charging sources. So I just want to point out to you here that, as I mentioned before, with our big battery, the 7.4, we could handle all of the peak amps that the XW Pro 6848 would draw during its highest surge capability. That is not a problem. However, our continuous rating, being 130 amp hour battery, is a little under what the continuous max charge current is from the XW 6848, which has a massive, great charging mechanism. That said, if you wanted to basically run a single battery and single XW Pro, you would need to derate that charger such that you're not driving it over the battery's capability for continuous ratings, because charging lasts, quite a long time in comparison to, say, surges or AC loads. At the same vein, also, if you look at the smaller battery there, you can see that with two batteries in parallel at just 6 kilowatt hours, we could easily handle the peak amps during a surge condition. However, on the charge side, we would need basically 3 of those batteries in parallel, or a minimum battery bank size of 9 kilowatt hours, in order to handle that 140 amps continuous. Now, that is much more flexible than many of the other lithium batteries on the market that don't have the high 1C current rating. And that's specifically why we've released this 3 kilowatt battery, because with 3 of those 9 kilowatts, it's probably the smallest battery bank you can put in conjunction with an XW Pro to handle all the current in full conditions. And just, summarizing for you, if you did put the full 20 kilowatt hour capability in a 9540 compliant battery bank, there is a whole lot of potential for charging those, whether that's DC coupling or you're going to use AC coupling, just leveraging the bidirectional nature of the XW Pro. But that's a lot of current handling right there, and you likely won't even be driving the batteries to their nearest capability. So again, in terms of the system design on the battery side, I just wanted to cover that quickly. We'll have more time for Q&A afterward, and we'll move on to the next slide where Jake's going to cover, I believe, the XW Pro design configurations.
All right. So with the XW Pro, everybody can hear me okay, hopefully. There's no limitation as it pertains to UL9540, whether you're how you're charging the battery, whether it's on the AC coupled side or DC coupled architectures. So you have full flexibility with our XW Pro platform. Shows the true versatility of the product. Again, as we mentioned earlier, the UL9540 standard applies to systems up to 20 kilowatt hours. Systems above that, you just want to check with your local AHJ. There is no requirement for closed loop communication in order to achieve the compliance with UL9540. So it can be used with just regular open loop, manual programmed settings. That is fine. In terms of those settings, you want to follow the guidance in our, we have a document under the technical publications on the product page for the XW Pro. The lithium ion battery solution guide. There's also a ZAN bus integration guide from Discover that reviews many of the same settings. So multiple resources you can go to if you need help setting those program settings. So we can go on to the next slide here. So for those of you less familiar with Schneider and their full product portfolio, you can see here it's pretty comprehensive in a number of different categories, those including solar charge controllers. We offer a line of 3 different charge controllers, both low voltage and high voltage. The MPPT 60 is limited to 150 volt maximum input on the PV side, whereas the 80 and 100 can be used up to 600 volt arrays. We have a full monitoring suite, including the edge devices, the Insight Home and Facility, I'll mention in the upcoming slides, and then full remote control and monitoring capability through Insight Cloud. Our Connect battery monitor provides shunt-based state of charge measurement, like a Coulomb counter, tracking amps in and out of the battery so that you can get a accurate indication of the battery's state of charge. Of course, if you're doing closed loop communication with Discover, all of that information is communicated from their internal BMS to our gateway. So the state of charge information would already be made available. We have our full line of distribution panels for balance of system components, both a full size power distribution panel for multi-unit systems, and then our mini power distribution panel for single unit XW Pro systems. Our Connect config tool is a useful tool for saving pre-configured settings files if you want to easily replicate those among other devices within the same family. You can save files in the native format using the config tool, and then update them easily, upload them easily to subsequent devices. You can also use it for AC output voltage calibration in multi-unit systems, which is a very nice feature as well. We do have full code compliance through our disconnect, our MPPT disconnect RS, which offers both arc fault and rapid shutdown compliance. And then we do provide an accessory for generator control called the AGS, the automatic generator start module. Offers full integration with the XW Pro to manage the AC2 secondary input, which is typically used for a generator. So you can start and stop that generator based on a number of different system status conditions. So we'll go on to the next slide here. So the key with the XW Pro is that you're really getting unparalleled backup power performance. The backup power, in grid connected applications, and especially with off-grid loads, you may have surges that require over 2 times the continuous power rating of the inverter, and the XW Pro is able to meet that surge requirement due to a large toroidal transformer, which provides that surge capability. Also internal to the XW Pro is a high-speed transfer switch, which is rated at 8 milliseconds response time when transferring over between, if the grid is lost and you're switching to backup power, it would take only 8 milliseconds, which is usually a flicker-free response time. Grid and generator input ports, as I mentioned, that's an important distinguishing aspect of our inverter solution. Many times our competitors only can support a single AC input. We can manage both. We do have an extremely reliable product. The XW Pro is the 3rd generation of the XW platform, which dates back to 2006. And there are thousands of units, even from the original XW legacy product family, that are still in use today and are operating without any issues. We do back our product with a 10-year warranty in the US. You get a free 5-year extension when you register the product online. We'll go to the next slide. So as I mentioned just in a couple slides previously, our monitoring solution is included is referred to as the Insight Energy Management Platform. Now this provides a number of capabilities, both locally and remote. It's important to point out that the cybersecurity is one of the things we take most seriously at Schneider. And so all of the advanced encryption, communication protocols, and procedure for storing user information are followed to the highest extent. So full data protection and security, both locally and remote through the cloud. And of course, this allows you to access your data from a number of different devices, again, both locally or remotely. We have, I think if you go to the next slide, these are our edge devices or gateways. The Insight Home and Insight Facility address a couple of different system sizes and price points. The Insight Home being sort of more of the entry-level solution for smaller residential systems. It supports a single ZAN bus network, which is what ties together our products on a communication network. And the Insight Facility is typically used for larger residential systems, small commercial systems even, that need more capacity for devices, as it offers a secondary ZAN bus network. So if you have large DC coupled systems with multiple inverters and multiple charge controllers, you can get them all on one device, and you'll have full visibility to data from all connected devices on both networks through your local means, which is Insight Local. If we go on to the next slide, I can show you. It's sort of a trifecta of monitoring platforms in the energy management through Insight. We have Insight Local, which is an internal web server hosted by the edge device, either the Insight Home or the Insight Facility. So that can be accessible on site, just pulling up a web page. Any device that supports a web browser can access that. Insight Cloud is the cloud version of Insight Local, basically providing you access to all of your site information for multiple sites. If you manage multiple sites, you're an installer, and you have them scattered around through a geographic area, you can see all of those sites listed in a single user profile, which is very nice. Full bidirectional control there as well to make settings adjustments, firmware updates, etc. And then we also have a mobile app called Insight Mobile, and that provides real-time monitoring of data for all of the same sites that you can see through Insight Cloud. And we'll move on to the next slide. All right, so I guess right here, I'll switch it back over to David.
Thank you, Jake. Yeah, so when Matthew distributes this presentation to you afterward, we've talked about a bunch of references from our websites and things and different things we have for you there that can support you in both the inspection permitting process and also just in terms of your design and integration of these. So what we thought we would do is just take some of the relevant links from each one of our respective corporate sites and sort of distill down for you the tools that are available for you specific to the combination of Discover AES batteries with XW Pro inverters and the pursuit of the UL9540 and pulling permits. That said, from the Discover Battery website, those are live links. You'll be able to click on them in the PDF that Matthew distributes afterward. But there's a product page overview. We have all of the relevant standards for our solar batteries listed on the website. So we do have a certificate of compliance there that you can print off on your own and basically have in your file or folder that you're preparing for your permitting package. Just to include that quite often, as long as they see the matching of inverter and batteries to those, that's all the questions that'll ever be asked of you in that regard. We've also included a link to the ZAN bus closed loop integration guide, which is, as Jake had alluded to, and Jack as well, is the means by which we connect and close the loop with the Schneider Electric products over ZAN bus. It'll give you a full explanation from terminations to network terminations right through to command and control settings and what is controlled dynamically, but it really explains what those devices are doing and how they're monitoring each other. And then finally, there's a link to the Discover's AES dashboard page, which is it links to the software and the processes by which you can access your battery data and historical data logs for health checks, for looking at the status and operation, lifetime capacity, etc., as well as doing firmware updates and essentially upgrading your battery over the course of its life. All of that is explained at that page. From the Schneider side, as referenced in the presentation, they have the application note for UL9540 there that explains essentially what the certification is, how it works in collaboration with our batteries. Additionally, they have they're a really well written, actually, XW Pro Lithium Ion Battery Solution Guide, which it will list our battery in there as one of the possibilities, but it's essentially a guide for any application of lithium batteries in conjunction with XW Pro. Very well written document, and it'll be very helpful for you all to read through there. And then finally, also on their website, they have the certificate of compliance for UL9540 as well. And just one note, when you are pulling the certificate of compliance, it's a bit of a weird snafu, and I think, to my memory, this UL9540 sort of joint company compliance is the first time I've seen it, but only one of the two companies can hold the standard. It references the batteries from the other. In this particular case, you are going to see the certificate of compliance was issued and released to the Schneider Electric organization. It has their name on the title bar as the owning company. And that is simply because we went through the CSA agency, which they use for the as the NRTL we use to get the compliance on this one. Our batteries were approved and listed through UL, our underwriters laboratories themselves, expressly. So, we won't have one that's issued to Discover Battery Corporation. It just is issued to Schneider Electric Solar, and it lists our batteries as being compatible there, in case you are wondering. We did have some information in appendices here. I don't know if we want to cover it. We're probably tied up against time, and maybe we should open the floor to the Q&A, but maybe Jake and Jack, feedback on that?
Yeah, I think we can go ahead to Q&A. That's probably okay.
Yeah, I think so too.
Perfect. Matthew, you want to adjudicate this? And
yeah. So I just quickly off the top, we just had a comment that the links on the page aren't active, so no one can click on them, but we will be sending out this presentation later today, and you'll get a copy of it where those links in fact are active to those pages on the various websites that David's been referencing. So hang tight, and we will be getting you that stuff. And in the meantime, certainly feel free to go and visit both companies' websites and have a peruse around. There's lots of information on both sites. So let's get into questions. We've got a few flowing in here, and just as a reminder to all of our participants, you can ask questions either using our Q&A function or the chat function in the Zoom meeting here. So let's get to the first one. I think this one is referencing back for friends at Schneider Electric. So the question is, I've used the AGS as an inbuilt function of the Connect 7048, but here I see that it's a physical module. Is this new?
Yeah, I could take that one. So it's not new. I think maybe what's causing the confusion is all of the XW inverters over the 3 generations they've existed have had a built-in aux port, and the aux port can also be used for simple 2-wire gen start. It may be that's what you're thinking of. The external AGS module can support many more variations and permutations of generator types. I think up to 14 different generator types in terms of the wire configuration. So if you have more complex 3-wire types of generators with glow and different types of signals that are required to start the generator, the AGS is going to have much more sophistication. And also a nice thing about using the external AGS module instead of the aux port is that it is smart enough to communicate over ZAN bus back to the inverter to know that if the grid comes back in a grid connected system, it'll shut down the generator. So there's a lot of additional intelligence built into the algorithms with the AGS. Hopefully that
Great.
answers the question.
Thanks very much. We've got a next question here, and I'm not too sure. I think this question was asked in our Schneider Electric portion of the presentation, but maybe I'll defer to both you and the Schneider Electric and the Discover folks. The question is why isn't the 10-year warranty offered here in Canada?
That would be a Schneider question.
Yeah, that's a very good question. It's something we're working on, but it has to do with our cost of supporting warranty in the United States versus Canada. There's more shipping costs and just a higher cost, but agree with the comment. I think we should offer a 10-year warranty in Canada as well, and it's something we're looking into.
Great. So here's another one. Would you be able to retrofit the storage/inverter solution to existing solar systems that are already set up with microinverters or string inverters?
I can take that if you want, or Jake.
Right.
Yeah, I can take it. So as I mentioned earlier in the presentation, the XW Pro supports both AC and DC coupled architectures. So if you are retrofitting an existing system, either with string inverters or microinverters, just purely connected to the grid without storage, you can AC couple those. You can use an AC coupled configuration of the XW Pro to add storage, and of course you have full compatibility with Discover's batteries in that configuration. You don't need to do closed loop communication. It can be AC coupled open loop with Discover, and you'll still have UL9540. So hopefully that helps to answer that question.
Great. Thank you. The next question we have here is, does Discover have a UL9540 or similar certification for any of its lead acid batteries, or maybe more specifically the OPZV lead acid batteries?
So the answer is no, and we aren't pursuing anything like that. The intent of UL9540 and things is more to deal with and address, the electronic, modern electronic batteries, the lithium platform batteries that are being utilized in that implication. So, there is, as you've probably all seen on the YouTube and things like that, there are concerns and safety concerns over thermal runaway, particularly with some of the other chemistries like NMC and such, overall capacity, fire suppression, propagation, etc. So it really isn't a standard that was driven or done with regard to lead acid batteries. That said, I don't know that they're excluded from that. It's just in our particular case, and if you can see the shirt I'm wearing right now, it says on the front of it, lead is dead. As it comes to residential solar and any kind of cycling application, the economics of lithium are so superior to that of lead that really it's a moot point, and we won't be pursuing any of that. I mean, my solar business, or the solar business at Discover, is lithium, lithium, lithium.
Great. Here's a question. I'm not sure which one of you wants to tackle this one, but I think it's an excellent question. How widespread is the awareness about and acceptance of UL9540 as a safety standard by AHJs? And what resources are there to help educate local officials, inspectors or fire departments, et cetera, about the UL9540 certification?
I could take that. So right now, it just really depends on geographically where you live. In the Northeast, UL9540 is a hard requirement in several states, New York, Massachusetts. California doesn't have a hard requirement in most utility districts yet. However, it's a widely recognized standard. So it's kind of a de facto standard. There's no questions asked if there's a UL9540 sticker. And that's kind of where it is in a lot of places. Kind of our expectation is this is like a lot of standards, like NEC standards, where over time, the entire US will probably adopt this standard. But right now it's sort of it's really the Northeast and California, maybe a couple of other states, and the rest of the states, it's probably not very well known. Now, to answer the question on resources, that's a really good question, and there's a lot of meetings going on with different groups just on the interpretation of UL9540, and I participate in some of these panels, and so I don't think this information is very widely distributed yet, and that's why there's a lot of gray areas as far as the interpretation. So, you know, I think over time a lot of this stuff is going to get defined and spread to the AHJs, but I think, you know, if you're talking to PG&E, there's widespread understanding of what of UL9540. If you're talking to a utility somewhere else, there's probably not much knowledge of it.
Great. Thanks, Jack. Next question is for you, David. What is the warranty of the batteries? How many cycles will they last for at full depth of discharge?
Okay, this question comes in from AJ. AJ, to answer your question on this one, the duration of the warranty, it's basically the warranty we put on our batteries is similar to an automotive warranty, where you've got a time duration and then you've got a mileage duration. In our case, mileage is energy throughput. So with our battery, and I'll speak to both the solar batteries, we do have motive versions as well, but in the stationary solar applications, they are a 10-year warranty. Okay, it's a 10-year duration, and that would be the time gate. In terms of the other gate, or the mileage, we calculate basically energy throughput, which is basically electrons in and out of the battery. It's a much more relevant measurement of I guess the work that the battery's done over its life than cycles. Cycles are a really poor interpretation of or estimate of. It just happens that they've caught on and it's a bit of a buzzword, but it's really an ineffective way of measuring the work that a battery has done over its life. So we measure energy throughput, and for each one of those 7.4 kilowatt hour batteries, and I'll just speak to the one for now, there'd be the same relevant energy throughput on the smaller battery, but it's 38 megawatt hours of total energy throughput on that battery. Okay, and that's captured and logged continuously through the data logs that you can access through the AES dashboard. If you wanted to put that into a cycle reference, and we specified a specific cycle depth of discharge at 80% depth of discharge, that would be 7,400 cycles, charge and discharge cycles of the battery, which would, you know, equates to that same 10-year goalpost as we have for the time value of our warranty. So, you know, again, under normal usage with 80% cycling, that's going to run into it. If you're microcycling or doing low cycle impact, say for demand charge avoidance and peak load shifting and these types of things, you know, you could get quadruple that number of cycles. That's again why cycles are kind of an immaterial count. You would more than almost certainly then run into the time limit on the warranty rather than the energy throughput limit. Where I see people pushing the energy throughput limit are typically people that are living entirely off grid, and they have a relatively undersized battery bank where they're consuming their electrical lifetime or electron lifetime of the battery faster than the time life expectancy of the warranty. Long-winded answer. 10 years, 38 megawatt hours, done.
Maybe just to follow on, is the 38 megawatt a sum total of energy in and out, or just one of them?
It's the sum total of electrons in and out of the battery.
Great, thanks, David. I've got a whole bunch more questions here. We'll try and get through them in the next 8 minutes here. So next question is, with multi-battery systems, are both AE bus and ZAN bus Cat5 circuits required to be connected and kept separate?
I can cover that one. So the way it's the kind of the two CAN channels are separate and distinct, and they're doing different things. Okay, what we do is we parallel the batteries together on what we call AE bus, which is a J1939 CAN channel. Okay, and what we're doing there is we're connecting the batteries together so that they can communicate with one another, and essentially at that point in time they're amalgamated or acting and performing as a single battery. So whether that's 2 batteries or 20 batteries in parallel connected on an AE bus, it essentially presents itself as a single battery block. That's all done on AE bus through that CAN channel. Now, and once that battery is combined and locked together or paralleled in terms of communications, you can select any one of those batteries to become designated as your ZAN bus battery. And your ZAN bus battery then is connected to the rest of the ZAN bus devices as just another node on that network. It is a single node, whether that's 1 battery or 20 batteries. Okay, so it's basically representing as one particular block. So we do all the amalgamation and combine the communications and status and things on AE bus. And then the portal for that gets it onto ZAN bus is a single battery, is denoted as a ZAN bus battery, and begins to act as a node there. When we are connected on ZAN bus, we are ostensibly getting to some of the devices that Jake alluded to earlier. We're essentially acting as the BATMON, or overtaking the BATMON device, battery monitor, because that has a lot of the PGNs and communications and status and things that we would represent. And then to do the command and control or leader, follower, master, slave sort of command and control, we are basically emulating their diagnostic tool, which is an advanced tool that allows for on the fly changes and command and control. So the answer is yes, they are 2 separate networks, both of them serving completely different functions. But as it pertains to the battery on ZAN bus, we are represented as a single device. You can, in the nature of some of the big systems that Jack has described before, let's say multi-cluster solutions with 3-phase operation, you can have 2 of our battery banks designated on the same ZAN bus network. Okay, all you would have to do is rename them Battery Bank 1 and Battery Bank 2, because you can't have 2 devices of the same name on a CAN network. But that would allow you basically up to 40 batteries in 2 battery banks, or 60 batteries in 3 battery banks, whatever you wanted to do that way.
So just to follow on to that, I think for the Schneider Electric folks, what are the max number of devices allowed on both Insight Home versus the Insight Facility ZAN bus?
I can take that one. So there's not a hardcore limit. There's some variability depending on how much data is being transmitted, dependent on the usage case. But in general, for the Insight Home, you can support up to, so it's a single ZAN bus network. So a single ZAN bus network can support up to 4 XW Pros in native split phase, parallel split phase configuration. It can actually support up to 6 XW Pros in 3-phase configuration. The reason for the increase in units there is that the inverters are actually configured as 120-volt single phase units when you're using it in the 3-phase configuration. So the data for the AC sources is only transmitted over 1 leg of that input. So you wouldn't have data coming from 2 separate legs. So there's a little bit more bandwidth for the 3-phase configuration. That being said, I would say 6 is sort of the max limit for the Insight Home. If you exceed that, especially if you're doing larger DC coupled systems with more than 3 charge controllers, you'll want to do the Insight Facility. Technically, you can do up to probably, I think we say up to like 12 high voltage controllers on the secondary ZAN bus network. But depending on how much data it's transmitting, maybe 8 or 9 is more realistic. You just have to keep in mind, again, when you're using the Insight Facility and you exceed 6 devices, you want to segment them into really different product families between the different ZAN bus networks. So you'll put all your inverters on ZAN bus 1 and all your charge controllers on ZAN bus 2. So if you tally it all up, it's probably closer to like 18 devices for Insight Facility, 6 for Insight Home, if you just want to throw out a number.
Just to expand on that thought, well, Jake's there and he's explained it so well. If you are going to use Insight Facility and you are going to be using both of these ZAN bus channels, just be cognizant of the fact that they're two independent ZAN bus channels that are just amalgamated in terms of data up in the cloud. And if our batteries, the Discover AES batteries are intended to be in closed loop within a system like that, the suggestion is to have the batteries on the CAN channel or the ZAN bus channel that is supporting the bulk of the charging. So in a DC coupled situation, if you've split up and you have your XW Pros on, say, ZAN bus 1 and your MPPTs on ZAN bus 2, you would put your batteries on ZAN bus 2, because then it would allow us to do the dynamic charge controlling and get the benefits of the faster charge and the longevity benefits on your battery from the primary charge source, which is almost always going to be charge controllers in that case. If you were in a let's say off-grid scenario with somewhat solar and somewhat diesel genset in terms of dependence for electrons for your charging, you pick your most active or your most relevant charging source. So you might determine that most of your charging hours are coming on the XW Pro, put the Discover batteries on that network, and configure the MPPTs for an open loop configurations with static settings. Alternatively, if you have your XW Pros on the one and your charge controllers and batteries on the other, you'll need to configure your XW Pro in static settings, open loop sort of settings for our batteries in the event that they are going to be charging from another source, grid, generator, or otherwise.
Good point. Good point.
Guys, we are at the top of the hour. I'm not sure if all three of you are able to stay on and continue on with some more questions or not, but we are at the top of the hour. So if you're willing to continue on, then we do have a load more questions here that are coming through.
Yeah, I can stay on.
I can stay on for a while.
Perfect. So next question, I think, is for you, David. Are the Discover batteries 9540A tested for installations in New York City?
They are not 9540A, and they will not be. Essentially, 9540A certification starts from the cell on up. And this battery being in the market now for 5 years, there was no such fire suppression or cell standard, cell testing and things like this when that battery was designed. The cylindrical cells we are using in that particular battery are just not going to be compliant to 9540A and the suppression requirements there. Our next generation battery, which is due to be released at the end of this calendar year, starts from the ground up with 9540A compliant cells, and thus speeds us through that certification. The flexibility of that for us will be that essentially the gate post or the defining limit of 20 kilowatt hours disappears or goes away when you have 9540A on the battery, and also because it's so comprehensive in terms of its suppression and other testing, FMEA, as I mentioned before in the earlier preamble, it actually decouples the battery storage from the inverter requirement, and it can be used agnostically or assumed to be used agnostically with an approved inverter charger for that application. So 9540A is a standard we're trying to achieve. It is more or less unachievable without tremendous unnecessary effort on our part with the existing battery Discover AES line as it stands today.
Okay, maybe a continuation on this theme. So I'm just going to read the question out and answer it as you can. So the Canadian code for 2021 will require batteries suitable for the purpose, which Appendix B says requires UL1973 or UL9540. Does this mean that Discover and Schneider will be foregoing the use of lead acid batteries completely?
I can take that one on.
Okay, yeah. I can take it on too, David.
There you go, Jack.
I think from the Schneider perspective, there are code requirements in different places, and if the code does require lithium-ion batteries, I haven't heard that before, but if it does, then obviously we will only work with lithium-ion batteries. But we have thousands of systems with lead-acid batteries. While we think that lithium-ion batteries are definitely going to displace lead-acid batteries are certainly not going to go away, especially in developing countries. So, yeah, we're going to continue to support lead-acid batteries and have a lot of installations with them.
Yeah, and again, Discover to this day, I mean, lead acid is the lion's share of our overall business. And it's certainly, in motive applications and such, there are still a lot of off-grid systems and things there. I will say, practically speaking, that I have not seen an off-grid system ever that is, fundamentally providing primary power that wouldn't benefit from lithium batteries. That said, as Jack notes, in the developing world, in many regions of the world, lead is the only accessible and only economically accessible solution. As you reference here, I mean, we're not changing the market. We're not dictating to the market what you can and can't use. The codes and standards are sort of doing that on their own and defining that. So yeah, we still make lead batteries that would be perfect for solar applications, as we do lithium batteries. However, in some regions, as we've talked about today with 9540, as we can talk about in IEC world, or the 50 hertz world, as Jack would think of it, there'll be different standards and things, and all we have to do is make sure we're as accessible as possible.
Okay, next question. Try and make sense of the question here. Can arc fault rapid shutdown sense low voltage arcing at less than 80 volts?
I could take that one. So that's with our MPPT disconnect RS solution, I believe they're referring to. I don't know that there's a minimum PV input limitation or a minimum PV input voltage in order to detect the arcing. I know on the battery side, it's down to, I think 22 volts. So it'll even work with 24 volt systems. And it does support, it can be used with our lower voltage controllers, which can operate up to 150 volt maximum input. I don't think there's any limitation in terms of being able to detect low voltage arcs. So I will say that should not be a problem. Again, as long as you're within the operating range of the MPPT controller.
Perfect, thank you. Next question is back to the communications discussion. Is Modbus supported?
So for our products, Schneider, we offer full Modbus mapping through our communication gateways. The edge devices I spoke about, the Insight Home and Insight Facility, are both Modbus compatible. The Insight Home has a single RS485 channel for Modbus. The Insight Facility actually has two RS485 channels on the IO connector. So there's like a 26 pin IO port on the Insight Facility, and you can see the mapping of the pinouts in the quick start guide, which lists which would be the configuration. There's of the two RS485 channels. Can't remember specifically which pins are off the top of my head, but they are listed in there. So Modbus RTU for serial communication over 485 and Modbus TCP over the Ethernet socket are also supported by the edge devices. And again, we have full Modbus maps for each of our supported devices available on our website.
Awesome. Next question, how many circuits can you hook up to the batteries?
David, do you want that one? Oh, David, you might be on mute. In any case.
There we go. Yeah, sorry, my screen froze up and I had to log back in. I would have to ask some clarification in terms of the question. We don't really, are you speaking of the AC circuits and maybe they're referring to the distribution panel aspect, or are you talking about sort of DC channels and maybe going to a bus bar solution or whatever? I mean, ultimately from the battery direct, once you're on the DC bus electrically, take as many feeds off that as you wanted. I mean, you could take taps off that for any other number of devices, as long as your ampacity was sized correctly and the batteries were able to support the current. The number would be, infinite. Practically speaking, though, I think you're probably referring to AC side, which would be, again, a fundamental that the Schneider guys would be dealing with that side, as they're the AC waveform generator. But, having come from the inverter business, I can say that the same is almost virtually true as well. It depends what kind of loads. You could have as many circuits as you wanted, as long as they're protected properly.
Yeah, exactly. Yeah, so it just depends on your inverter configuration. Single inverter system, again, can support up to 6.8 kilowatts of continuous loads at 25C. So again, depending on how your load distribution panel is outfitted, you can fit any number of circuits in there without exceeding that limitation. But again, you also have surge capability as well. So you just have to keep that in mind.
Yeah, and just kind of a follow-up to that is, when you're sizing your system, you need to size it to both your continuous load and to your maximum load to make sure you have enough inverter to cover those loads. And then once you do that, then you need to size your battery bank to determine, okay, how much runtime do I require for that continuous load?
That's your capacity metric. Yeah, and that's your capacity metric. And then, as I discussed earlier, the other thing is to say, how much current does this system need, or current carrying capability does this thing need? So there's two measurements on the DC side or the battery side.
Awesome. Okay, next question. Can the ZAN bus create essentially a microgrid to keep powering connected loads indefinitely in the event of an extended blackout for grid-tied systems?
So I'm not 100% sure about the wording there. I guess if what you mean by can the ZAN bus. The ZAN bus is just the network protocol for communication. But if you're just talking about the inverter in general, being able to supply protected critical loads basically continuously, up to its output rating, that's what it's designed to do. So it really depends on your battery capacity at that point, how much autonomy you have in order to keep powering those critical loads. But again, for on the Schneider side of it, for our inverter component, it can run at continuous output continuously for an indefinite period of time, depending on what your autonomy requirements are.
Jake's too modest. It's actually the ultimate machine for doing extended long-term backup. I mean, as long as you've got a source of electrons, either a generator or rooftop solar that can support your loads and replenish the electrons in the battery bank, that is the ideal machine for it. You can think of extended backup as being off-grid, and it's an off-grid machine.
Yep. Well said.
Awesome. Next question is, I have an XW4548 with the Connext COM box, and here's part number 865-1050-01. I did not receive the email stating that the device will not be supported. What are my options / for updates?
So the XW4548, I believe, was from the original legacy platform. Those units will continue to operate for as long as needed. You can actually update the firmware of those older legacy units to the XW to the firmware of the XW Plus. You can't update to the XW Pro platform, which would be skipping a couple generations, because it actually has an entirely different control board assembly. So, but the firmware packages for the XW Plus can be retroactively applied to the older XW legacy inverters if you want to enable some additional features and protections as the product developed over those two generations. There is a procedure for how to do that. It's basically just renaming the file name when you the .xfo firmware file. If you're doing a firmware update to your existing legacy XW, you can change it to basically the convention of the XW Plus, and it will allow it to upload that newer firmware. You may get a few extra features, but certainly, you know, the current version of the platform is the XW Pro. We added a lot of improvements that again required an entirely new control board. So certainly, if your unit is at the end of life or not working, not giving the expected performance as it used to, then I would encourage you to update to the newest version, which is the XW Pro.
But you can continue using the CommBox and the 4548. You also have the option of upgrading to get the gateway, or what we call Insight Home and Insight Facility. I actually have an original XW4024 at my house, and I use that configuration myself. So it still works fine. There's just not any new updates that are happening with either the 4548 or the CommBox.
Great, thanks, guys. Last question. Did I understand correctly that your software does the math to convert fractional daily usage into complete charge/discharge equivalent cycles?
I'm assuming you're talking about the battery data downloads. Interesting question. So we are continuously logging and monitoring the energy in and out of the battery. And that's a perpetual count that goes on through the life of the battery, represented in the data logs in 5-second increments. Okay, so, you know, that granular. We're actually measuring it, you know, sub 5 seconds. It just becomes a huge waste of data space to present it that more. So we look at averages within a 5-second window. You could definitely interpret that information in terms of cycles by looking at one of the other categories in the column, which is basically, you know, whether the current in the battery is coming in or out. Is it a positive number or negative number? And do a cycle count based on that. Ultimately, you know, it would all the information you would need or want to look at the battery in any level of detail is there and presented. So it really comes down to specific use case and specific need or want on your part as to how to interpret that information and present it in such a way that it's useful to you. Again, I think if you pull the data logs from the battery, from one of our batteries at some point in time, and let's say, you know, look at a month's worth of data, you would be overwhelmed with what we can show you there. From, you know, down to the individual cell measurements, to the cell block temperature, to charge discharge cycles, to the relay state, any of those types of things is there. So, you know, maybe have a look and see, and if you have specific questions, you can always go to our support page on our website at the www.discoverbattery.com and just put your inquiry through there. Some of the videos we have on that AES dashboard web link that I had up earlier that you'll see in this document when it's circulated, that would walk you through some of the data interpretation as well.
Awesome. Well, listen, we've reached the end of our questions, and we've certainly are over time. I just want to thank all of our panelists for being on the call today, and all of you who've joined. We will be circulating out the recording of the presentation later today, along with the slide deck itself, so that you can click on those links and review the materials with, later on, or with any of your team who are not necessarily able to join us today. So thank you very much to our panelists. Thank you very much for all of you in attendance. And with that, we'll close our webinar. Thank you very much.
Thank you all.
Thanks
Thanks,
everyone.
everybody.